All right, thank you very much. My name is Tim Yeager. I manage the vertical business practice at Tarana. And what we will be covering today is some basic requirements of the energy networks. Who is Tarana Wireless? What makes us different from traditional wireless networks? How Tarana addresses some of the requirements of energy networks. Rough roadmap, very high level. Some examples of deployments and questions on how to engage Tarana. So I do have 3 examples of deployments on this webinar. All of them are oil and gas, but I do have some other on, one is a solar, one is a hydro type of deployment. So when we're talking energy sector, we're talking oil and gas, hydro, solar, wind power, and then also just the basic power generation networks that we're seeing out there as well. These are some of the requirements of energy networks. This is not an all-encompassing list by any stretch of the imagination, but these are common in all of the networks that we're seeing in these types of deployments. This vulnerability are key for these networks. The companies that are deploying this don't have the resources to constantly be maintaining the radios in harsh conditions. It's nice when they're really nice conditions to work in, but in the industrial networks, especially in the energy sector, they're not necessarily the nicest RF environments or even environmental conditions that are out there. They have to be easy to deploy. The groups that are deploying these networks aren't getting the human resources that they used to have or necessarily need to grow these networks and to do everything that they're being asked to do at this point in time. And you also have turnover from time to time. So you need to have an easy to deploy network that you can train quickly the remote operators and people who are deploying this in remote areas. And you need to be able to manage these networks remotely. On some of the networks that I'm working on here, it may be 2 hours drive time each way to get to some of these remote sites. And what that does is, if you can manage remotely, you're now dispatching to fix as opposed to dispatching to determine what the problem is. Increased demand for data. On a lot of these energy networks, where they used to be getting data from these networks once a day, we're down to 5-second data and as close to real-time data that they can. And they're also, what used to just be SCADA data is now SCADA video, remote calling on job sites. So there's a lot more applications being run on these deployments so they can get more data to them. Because you are monitoring remote sites, an upload speed is as important, if not more important, than download speed to these networks. And the greater reliability and more upload speed that you can get better service to these networks. Some of these networks, when you have an outage, not only is it a soft cost, but there's potentially fines that are included in with that. And again, data security. When you have a network and you're transmitting data over the air, you need to make sure it is a secure network, not a backdoor into a corporate network, or that that data has any type of vulnerabilities to it. So who is Tarana? Fixed wireless access broadband provider. Been around more than 12 years and had more than $300 million invested in R&D into the putting up. And with products, sorry, I just a note that says our audio is a bit laggy. I am plugged directly into the computer, so I will try to take that into consideration going forward. The evaluation of our company, we have well over 28 patents on our product, and currently we're offering the 3 gigahertz VRS version. We are designed on the means it's a silicon on up design. When we started delivering product to the market in October of 2021, we had 2 main customers. We're well over 200 now and growing every week. And these are production networks, not just pilot networks that are out there. We are designed and prototyped out of Milpitas, California, Bay Area, California, San Francisco. And we qualify for Made in America. I know that may not mean that much outside of the U.S., but with some of the deployments potentially being U.S. military bases or NATO bases, that does mean something for those. When ARP was developed, there were 2 main chipsets out there on the fixed wireless broadband radios, the 3GPP chipset and the Wi-Fi chipset. Both those chipsets are fantastic for what they're designed for, but using those chipsets for fixed wireless access, they have some inherent flaws. So when our founders started developing up this product, they decided that they were going to build a product basically silicon on up. So it is from a chip on up type of development that they have done. So majority of the fixed wireless access out there, you still use those 2 chipsets, and we're going to address Wi-Fi first. Wi-Fi, you're probably hearing a lot about 802.11ax right now. Still designed and optimized for indoor wireless access with your computer. You only have beamforming on the access point side or the control side, no beamforming on the remote side. You lack support in a fixed wireless deployment of near line of sight and non-line of sight type of areas out there. So it is only a line of sight type of product. The existing parts of the spectrum, they lack interference, immunity, and interference mitigation. And with the new parts of the spectrum being added, the new parts, 802.11ax, it's already been occupied by incumbents. So you eventually run into the same problems that you are in Uni 1, 2, and 3. And you have performance degradation. You have overhead up to 40%. And then, as any Wi-Fi product, as you add the throughput to each as well. and you don't have the same spectral efficiency that Tarana has reuse frequency 1, which basically means you can use the same frequency on all 360 degrees of a deployment instead of having to alternate parts of that frequency to mitigate self-interference. So what I've done here is some cases showing actual performance of the 802.11ax versus the current model of Tarana radio. So the big thing to keep in mind is 802.11ax uses 160 megahertz of to get the bandwidth they are saying that they can provide. Very few parts of the world offer an uninterrupted 160 megahertz portion of the channel that they actually deploy at 4. So what that means is with our only using 80 megahertz of channel, and what we've been able to do is break that up into two 40 megahertz systems that don't have to be right next to each other. So you're able to deploy Tarana where you can't deploy AX. And all 5 of these use cases start off with a single use case that is super simple, not complex, the easiest out there for everybody to deploy, and it moves down to the most complex. As you can see, we are affected by physics just like everybody else is, but we don't take the impact that other fixed wireless manufacturers do absorb in the same business case as they get more complicated and more involved. So 3GPP or mobile is not the answer either. So it uses the same chipset that's in your system, and what that relies on is the license spectrum. Again, it doesn't have the clearance trajectory that voluntaries. So in one direction beamforming, not bi-directional beamforming. And the strength from the AP down to the remote node is stronger than the remote node to the AP, so it leads to poor performance. Again, limited capacity out there. It doesn't have the ability to support as many remote nodes as Tarana does, and it does use more spectrum because you have to alternate spectrum so you don't get self-interference. So that's to address some of the self-interference issues. So we have the ability to cancel up to 40 dB of our own radio noise that we have coming from our own radios. And what that does is instead of shouting in a room full of noise, we're able to hold a normal conversation. It allows us to viable performance. We also have the ability to cancel up to 40 dB of difference from other radios that are out there deployed that are not associated with our network. Again, gives us the chance to get better performance, better distance, better throughput on there. We beamform in both directions. So what that allows us to do is get better signal strength out there, adjust to constant changing distance, and a better performance. So just one within allows us to use more parts of the spectrum, other parts of the network, which allows for greater support for larger deployments. So challenging today in the real world. Obstructions everywhere. Redeployment that's out there. There is and social I call them nearline site, and most or all of the line of sight for me. Unlicensed interference. We interference slang. Yeah, you put a null in the boards, any interference of the radio source coming in. Again, that allows performance, rely on through the use of one the ability. What was that? Sorry, I had some feedback come through.